Good morning, everyone. Good morning. Hope
How you
all
doing,
is
man?
well. I'm good. I'm good. All right. So, if I'm not mistaken, today we're supposed to be getting into chapter 7.
Excuse me, good morning. I'm
Mhm.
gonna disconnect and join on my computer, if you don't mind.
Okay. No problem. No problem.
All right, thank you.
Mhm. System linear. Yep. We're looking at lines and angles today. Where is my. Okay. Well, my notes not coming up.
This is our chapter 7.
Say again now.
This is our chapter 7. Now it's
Yep.
always changing.
Yeah, we're gonna start at chapter 7. I'm gonna rewrite these titles a little better though. But yep, starting lines and angles. So let me rewrite this a little better. Only reason I'm writing it like this, just copy down the title of lines and angles. Then we're gonna go to another note sheet. So we just right now we're just looking at lines and angles. Just want to write this stuff a little better.
Well, you said something about
Mhm.
there being like a list of equations that'll make this easier. Is there somewhere that we can find that, or are you gonna give that to us?
Now, when you say list of equations, are you
Like a
talking
cheat sheet?
formulas?
Yeah, the formulas. Yeah, like
I can Google something. Yeah, I can see if I can find something. If
no, because you mentioned it last class. You said chapter 7 is more of like a flow, and there'll be like a formula for each thing, and as long as you have the
yeah,
formula, then you can
yeah,
perform.
when you
I
talk
just
about
wanted to.
yeah, yeah. So we talk about perimeter area and volume, right? There's a formula for each shape,
Mhm.
and your success is basically dependent upon you using the proper shape with the proper formula. Yeah, so yeah, I can find something and shoot that to you guys. Yeah,
Awesome, thank you.
yep. Waiting as only reason these are listed this way is because I have all of those notes on another sheet. Um, so now I'm just rewriting them just so they'll look better. Mass grams and then capacity. All right, so like I said, I just wanted to make that neater. All right, so let's look at lines and angles first. Go to, hold on. What section is it? 7.2? Okay, must be 7.2. All right, there we go. So of course the title's not the same. It's just lines and angles. All right, so let's go. You guys don't have a problem like that. Let's look at angles. So that's where we're starting with angles. Two rays with the same endpoint are angles. It would be an angle. That endpoint is called the vertex. Can I scroll up? Oh, 1 second, let me see something. Yeah, okay. Types of angles. So your acute angle would be between 0 and 90 degrees. A right angle is exactly 90 degrees, and you can never assume that you have a right angle. You have to see this square there, or it has to be notated in the direction this is a right angle, but you can never assume that you have a right angle. Obtuse angle is an angle measurement between 90 and 180 degrees. Straight angle is 180 degrees. Just a straight line. A full rotation or revolution is 360 degrees. All right, next relationship, complementary angles. Two angles that add up to give you 90 degrees.
What is that? Is that 1 degree and 40 and what? Is that 8 or 89?
Yeah.
89.
Mm-hmm. So right here is 50 and 40 degrees. They add up to give you 90. And then 1 and 89 add up to give you 90. Yep. Sorry about that. My daughter came asking for pizza bites. I had to, had to get it straight.
I feel.
Everybody done with complementary? Supplementary angles are two angles that add up to give you 180 degrees. So 150 and 30, then 2 and 178. All right, is everybody okay? So first example says, given that the measure of ABC, let me scroll up. ABC is this angle right here, right? ABC. So given that the measure of ABC is 84 degrees, find the measure of X. So whether you set this up as an equation or not, the main thing is you recognize that you would subtract 47 from 84 in order to figure out what X is. So if you set it up as an equation, this is how you would be, looking to set it up, because X plus 47, gives you ABC. But if you don't set it up, make sure you just understand that the relationship is to subtract 47 from 84 in order to get X. And so X is equal to 37.
I got a question for you.
Yes, sir.
Where you get X from?
Oh, they gave it to you. They said right here. They said that's the missing. They want to know what is X equal to. That's the missing angle. They give you this diagram right here.
Okay, I didn't know. Okay.
Mm-hmm.
Okay. All right. I thought that in your example, it says, given that M, I thought that was a greater than sign. I don't.
Yeah, that's why I did this little red right here. Yeah.
Okay.
The measure of angle ABC. Yeah. So that was my fault. I didn't, I didn't.
You wrote it. I just did. I was busy writing and I didn't. Yeah.
Well, yeah, I didn't point that out. So yeah, that was my fault. Mm-hmm. All right. Is everybody still copying? I want to go up to something real quick. All right. So I forgot to show you guys parallel and perpendicular lines. So parallel lines are lines that never touch or cross, have the same slant, same incline. And perpendicular lines are lines that create a 90-degree angle at their intersection. So you can never assume, once again, that you have 90 degrees. You have to see something that signify the 90-degree angle, whether it's that square or in the direction they tell you have perpendicular lines. So that means they have a 90-degree angle, something along those lines.
So what if they don't cross what if they don't make a 90?
Oh, then they just lines that intersect. They, ain't no name for it. They intersect the lines. That's just it. Yeah. So these are special situations. Other than that, you just got intersecting lines. All right, can I move off the page? Anybody still copying? Everybody good? All right.
But can you stop back at where you scrolled up from
Right here.
on the example, so I can copy the equation way to do it.
Mm-hmm.
And so this is how these things are going to look in the questions and on the test.
Yeah, they'll give you a diagram and
no,
then
what
tell
about
you.
to the right of that? So they'll tell you to write the equation form?
No, I was just showing you the equation way of doing it. But I was saying as long as you see the relationship that subtracting 47 from the 84 is how you would get the missing piece, that's all that matters. I was just showing you, I got to show you this. You know what I mean? Because that's the job. But as long as you see the relationship, you still can find the answer, 84 minus 47,
Right.
because both of these
Because it's got to equal 90. Yeah.
Well, in this case, it's 84.
Oh.
Yeah. This case is 84. Now, if they did this, and then they had the box in there, then you would say 90 degrees because that red box or that box in there would say that's 90 degrees.
So can you tell me all right, so break down what that M, the measure of ABC. So what does that mean? Like that?
It's just saying that the measure of it is 84 degrees. So
measure of A, B, and C. A to B to C.
You're right. This right here.
All right. Okay.
Yeah. ABC. Right. Mm-hmm. And so that means both of these, X and 47, adding together gives you ABC. All right. Next thing is vertical angles. They're formed by intersecting lines. The non-adjacent angles are vertical angles and are equal. So you're talking about the opposite angles from each other. They're equal to each other.
Okay, so down in the bottom in the blue, is that the equation that we're going to see?
Well, that's the relationship. It's telling you that angle 1 and angle 3 are equal. And then angle 2 and angle 4 are equal. So the opposite angles are equal to each other. And so those are your vertical angles.
Okay, so that's vertical angles always will have opposite angles that will be equal. Is that correct?
Mm-hmm.
That's correct?
Yep.
Oh, good. Surprised myself on that one.
And that's a relationship that's going to keep coming up when we, as we go to finding these angles and stuff like that. So, yep, if you ever see that relationship, then you can use it to establish equality. Yep. And in the green right there, it says a straight line is a straight angle and it's always 180 degrees. So in other words, when I look at this line right here, 1 and 4 will add up to give me 180 degrees because it creates a straight line. So any two angles that add up to 180 degrees, any two angles that give you a straight line will add up to 180 degrees. So 1 and 2, when you add them together, should give you 180 degrees because they create a straight line. So that's all I was emphasizing with that green statement, is that any straight line is going to be 180 degrees. All right. Can I scroll up to the problem? Good. All right, I'm going to erase some of this stuff so we can walk through it. Hold on a second. First, let me do this. All right, and this wouldn't be here. As a matter of fact, none of this would be here. Just trying to show you what the diagram would look like originally. So don't copy this stuff yet. We're gonna walk through it in a second, but I just wanna make sure you see the problem. So the problem is just find the measure of A, C, and D, and they give you B. And so they give you this diagram right here. So find the angles, find the measures of A, C, and D, and they give you B. So we have two lines intersecting. And so whenever you have two lines intersecting, they create these vertical angles, which is the relationship we just finished talking about. And so like your classmate mentioned, opposite angles will be equal to each other. So B and D will be equal to each other. A and C will be equal to each other. So that's why I have the double lines and the single lines there. All right. So over here, oh, had my eraser still on. Okay. So over here on the right is the calculation of how we would find out which angles go with which and everything, how everything is measured. So notice B is given. That's that 115. Once again, B and D are going to be equal because they're vertical angles. So that's how I got D right here. D is 115. Notice I put vertical angle with B. So that's the rationale there. Then it doesn't matter which one you find next as far as A or C is concerned. We have a straight line between A and B. They create a straight line. So that's why I subtracted that 115 from 180. And that gave me 65. Because right here, notice it says straight angle with B. All right. And then to find C, C is opposite A. So that's a vertical angle with A. So whatever A is equal to, C should be equal to as well. So since A was 65, C is 65. All right. Questions on what we did there? We should be okay. So we use two principles here. We use the vertical angle and then straight line or straight angle relationship to find our angles. All right, very good. All right, so let me erase some of these circles. All right, so L1 and L2 are parallel. T is a transversal. That's just a line that intersects two parallel lines. All right, and that is A. Oh, I keep leaving that eraser on. So that is AB DC, and then WX ZY. You know, so whenever you have two parallel lines and then a line running through both of those parallel lines, some relationships are created, which will have equal angles. So alternate interior angles. So when you say interior, we're talking about the inside angles, the inside of your parallel lines, interior, and they're alternate sides of your transversals. So you're talking about D and X and C and W. So they're going to be equal to each other. So alternate interior. So the name will tell you what we're talking about. Alternate sides of the transversal and interior transversal, excuse me, and the interior angles. So they're going to be equal to each other.
Pause right there for a second.
Yes, sir.
I just need to copy.
Yep, you're fine. So next one, alternate exterior angles. So going back to the diagram before I scroll all the way up, remember the interior with these angles. So alternate exterior are going to be these outside angles, A and B, Z and Y. So A and Y will be equal to each other. B and Z will be equal to each other. Once again, if you lean on the name, alternate exterior. So we're talking about on the outside, the exterior of the parallel lines. All right, and then the last relationship, corresponding angles. They are equal. So going back to the diagram real quick. So what this is saying is that these four angles correspond to these cluster of four angles. So you'll see A and W are equal, B and X are equal, CY, DZ are equal.
Can you say that one more time, man? I'm lost.
Okay. So all it's saying is that this cluster is equal to this cluster. So A, W are equal, B, X are equal, Z and D,
Okay.
and then Y and C.
And which one is that?
That's the corresponding. In other words, that first cluster corresponds to the second cluster. They're basically mirror images as far as their measurements are concerned.
So eventually we'll add all the angles together. Is that what's happening, or we just
Well, what's going to happen is they'll give you one angle and then ask you to find the rest.
identify the angles?
Mm-hmm.
Mm-hmm. Okay.
Are we going to have to, go ahead. Are we going to have to tell you if it's a corresponding or if it's a alternate, or
no?
Are we just going to have to be able to do the math?
Do the math. So you have all of these just different relationships, whether it's vertical angles corresponding, straight angle, alternate. You have all of these at your disposal to use to try to figure out what these angles are. So there'll be different times that you can use multiple ways of getting the answer. All you have to do is use one, but whatever way you use, you just have to come up with the right number. They're not going to necessarily ask you, did you use the corresponding angle relationship? They're just going to say, what is the missing angle? And so these are just different ways you can find, the relationship. So in the next diagram, next example, that's what we will be doing. Just give you guys a chance to finish off corresponding angles as far as taking notes. All right, let me erase this. Okay, so in the diagram, L1, and whenever you have those double lines like that, that means parallel. So L1 is parallel to L2, and the measure of angle F is 58 degrees, and they tell us to find the missing angles. All right, so that's all they would give you is one angle and tell you to find the rest. So when I scroll up, you'll see I already have it filled in. I guess I'll just leave it up and then just explain to you how I got, what versus me erasing and then writing it back and all this stuff. So, all right, so let's scroll up. So I would have found the bottom four first. So I wouldn't have found these yet. So the first thing I recognize is that I have this angle right here. I have angle F. Now, opposite of angle F is H. So that's why I have right here, angle H is 58 degrees because it's a vertical angle with F. All right, everybody okay with H? So no calculation, just recognizing it's opposite of F, so it's equal to F. All right. Then the next one I would find is G. So G is a straight line with F. So that's why I subtracted it from 180. And so that gives me 122. All right, any problems with that? Now, if I wanted, I could have found angle E because that's a straight line with, I could have subtracted that from 180, which would still be 122. So that's why I was saying, like, you have different ways of finding this stuff out. It's up to you and your vision and your imagination as to which way you go and what relationships you remember. Now, E and G are opposite of each other. So they will be equal. And that's why I have vertical angle with G for E. So before I go to A, B, C, D, questions on E, F, G, H. All right. So now, once again, there are multiple ways, multiple relationships that we have in order to be able to find these other angles. If you want to do a corresponding angles with all of them, you have all four of these correspond to it. So A and F, that's what I got right here, corresponds together. So that's why both of them are 58. B and G correspond together. That's why both of them are 122. I could have did corresponding angles here as well. I decided to switch it up and just do vertical, just to show that you can get it another way. And so A and C are vertical angles with each other, because they're opposite. B and D are vertical angles with each other because they're opposite and they end up being the same thing. So once again, there are multiple ways you can play with getting these values. You just have to make sure you use the right relationships and you always get the same result. And notice even when you're dealing with this, there were only two answers, 58 and 122. You just have to make sure you put them in the right spot. All right, questions on that? Let me see, I think you guys got triangles in here. Yeah, thought so. Okay. All right, now scroll up. Last thing out of this section, angles of a triangle. They always add up to give you 180 degrees. So if you see a triangle, they're going to assume you know that. So they're not going to mention they add up to 180 or anything like that. If you see a triangle, they're going to assume you know that the angles in the triangle add up to 180 degrees. All right. Let me erase some of this stuff. 80, 60. Okay. So in the diagram, the measure of angle C is 40 degrees. The measure of angle E is 60 degrees. Find the measure of angle D. So this is the diagram. The 40 and 60 wouldn't have been there, but I put it there just because they already gave it to us. But this is the diagram right here. We want to find angle D. So they give us C and they give us E. Now A and B are there. They don't ask us to find A and B, but we have to find A and B in order to get to D. So let's scroll up with my stuff. All right. So C was given, and I think I got E down here too. Yeah, E is given. Now, the first one we can find is A because they are opposite angles. They're vertical angles. So A is going to be equal to E, which is 60. All right. So if you want to throw 60 in there. Now, notice we have a triangle right here. So I have C and I have A, but I don't have B. I know that all of those angles in the triangle equal to 180. So I subtract 60 and 40 from 180, and that'll give me the angle of B. And so notice right here, angles of a triangle is the relationship that we have there. That gives me that. And then to find D, A and B create a straight line. So I can subtract that 80 from 180, and that'll give me 100. And that's because it's a straight angle with B. All right, any problems, any problems? All right, so that's it for 7-1. Got some time so we can at least start 7-2. Is everybody good before I go to the next page? All right, this is 130. So next one, we're looking at 7-2 is perimeter, area, and volume. All right, so we're good to go to the next page. Perimeter, area, and volume. All right, so let's look at the difference between the three. So let's look at a rectangle in all three phases: perimeter, area, and volume. So if you're talking about the perimeter, you do not need a formula necessarily for the perimeter. It's just adding up all of your sides. So if I have a rectangle, I'm just talking about like if you're talking about a house, you're talking about fencing, like your yard, the fencing would be the perimeter. And all you would do is add up your sides. Now the rectangle has a formula for the perimeter, that's 2L plus 2W. But once again, you do not need a formula to calculate the perimeter. All you do is add up all your sides. In the green box, just emphasizing when you're done calculating your perimeter, it will be left in the regular measurement. So if it was in inches, it stays in inches. If it's in feet, it stays in feet. If it's in meters, it stays in meters. I'll show you the difference in a second, but that's what's going to happen with perimeter. All right. Area, you need a formula for the area. And like I was mentioning to Mr. Tucker, or like he brought up, there, I'll try to shoot you guys a formula sheet that has, if not all of them, majority up there. But all the formulas, until I do that, you can always Google, ask Siri, ask Alexa. They don't change. You can find those formulas anywhere. So until I get you that sheet, all you got to do is say, what's the volume of a cylinder? And it'll pop up. All of those, they don't ever change, no matter what book, no matter what math you're dealing with. So now the formula for the area of a rectangle is length times width. All right. Now, each shape has its own formula, so you can't use this for a triangle. You know what I mean? So keep that in mind as well. Every shape has its own formula. And the area is the amount of space that a shape takes up two-dimensionally. So you're talking about the inside, how much space it takes up. You know, perimeter is just the outside, just the, outside barrier. The inside, the amount of space that a shape takes up two-dimensionally is your area. And notice when we finish calculating, your area is going to be in squared measurement. So it'd be inches squared, feet squared, or meters squared. Whatever your measurement is, it will be your measurement squared. Mr. Tucker, we in your bag, huh? I see you chilling back.
I've been doing this for years, man.
Right, I remember you telling me.
This is an easy flow.
Your whole demeanor was like, ain't no need.
No. I still, because there's always room to grow, man. So yeah.
You know, I'm just messing with you because I can, man. All right, and then the last one is volume. And of course, we're going to go through examples of it, but I'm just giving you guys a straight comparison between the three. And the volume is the amount of space that a shape takes up three-dimensionally. And so here we have a cubic rectangle. Notice now it's not just length times width, but it's length times width times height. And our measurement now will be calculated. After you calculate your volume, it will be left in cubic measurement, whether it's inches cubed or cubic inches, feet cubed or meters cubed. It will be left in your cubic measurement. And once again, I don't know if I said it, but you need a formula for volume as well. All right, can I scroll up? Do a few examples. So always make sure you hold true to the directions, what they ask for. Because let's say if you try to find the volume in this problem, you wouldn't be able to do so because they don't give you enough information. It's not a three-dimensional figure. So make sure you're paying attention to what they're actually asking. So here they ask us to just find the perimeter in the area. And they give us a rectangle, which is what we were dealing with generically a few minutes ago. We have 30 inches for the length, 20 inches for the width. Using the formula. Once again, This formula only holds true for a rectangle. You cannot use it for a circle or for a triangle. So this is the perimeter for a rectangle, 2L plus 2W. That's because this side and this side is equal, this side and this side is equal. So that's where to get that from. Once again, if you just add up your sides, get the same answer. So 2 times 30 plus 2 times 20, 60 plus 40 is 100 inches. Then to find the area, it's length times width. So that's 30 times 20, and that'll be 600. But notice our measurement is now inches squared. All right, can I scroll up for another one?
So the reason why it's squared is because you have four sides, correct?
Well, it's squared because you have inches times inches right here. So mathematically, that's why it's squared, because inches times inches would be inches squared. Just like if you had x times x, that's x squared.
Thank you.
Yep, no problem. And then the same thing happened with volume. Remember, that's length times width times height. So that's inches times inches times inches, which will give you cubic inches, or inches cubed. All right, so next one, find the area. They give us a triangle. So the formula for the area of a triangle is 1/2 base times height. So our base is normally the bottom side of your triangle, and then the height, the height of the triangle, how tall the triangle is. So that's 12 and 6. So 1/2 times 12 times 6. Now that 1/2 doesn't go to both terms. That's all one number. 1/2 times 12 times 6. So 1/2 of 12 is 6. 6 times 6 is 36. And that would be centimeters squared.
What is the B in the formula stand for?
What's going on? Okay, your base. Yeah, base of your triangle.
Base times height.
All right. Scrolling up. Here we have a trapezoid. So the formula for the trapezoid, 1/2 height times A plus B. Normally A is the top side and B is your bottom side, keeping in line with B being your base of your figure. But those kind of really are interchangeable. Notice they're in the parentheses together. You just add them together. As long as you have those two sides, the top and the bottom inside of that parentheses, adding them together, you're good to go. Then you're taking the height of your trapezoid, and that'll be the 7. So that's what I have over in the green, just establishing that A is 6, B is 14, H is 7, and then we plug them in accordingly. So now, if you have a calculator, you just throw it in the calculator like this, then you don't have to worry about order of operations. But if you don't, and you're doing it by by hand or in your head, You would do what's in the parentheses first. 6 plus 14 is 20. Then, you know, I'm doing everything on the screen. So what I would do is you have 1/2, 7, and 20. 1/2 doesn't go into 7 evenly, but it goes into the 20 evenly. Multiplication, you can multiply them in different order. It doesn't matter if it's all multiplication. So 1/2 of 20 is 10. 7 times 10 is 70. And once again, it's the area, so that's square footage. All right, any problems before we go to the next one?
Give me 1 second, let me finish copying.
Yep, you're good to go.
All right, I'm good, thank you.
Yep, not a problem. All right, so let's look at circles. So here we have a circle. If you have a line going from one side of the circle, to, well, not one side, one point on the circle to the other, going through the center, that's your diameter. If it's going from the center to any point on the circle, that's your radius. So the relationship between the two is that your diameter is half of the diameter is the radius, and then 2 times the radius is your diameter. So if you have one, then you have the other. So they don't necessarily have to tell you which one they have as long as they give you this diagram. So in other words, they don't have to say diameter is. If they give you a line going through the center from from point to point, then that's the diameter. If they give you this diagram, then that's the radius. So just make sure you hold true to what figures they give you. The reason why is key because we'll be plugging in using the radius most of the time. But so in other words, in this green, if they give you the diameter to be 30, half of that would be 15 as your radius. Or if they were to give you a radius, which is 7, you multiply that times 2, then you have the diameter, which is 14. So if you have one, then you automatically have the other by applying the relationship between the two. All right, let's scroll up.
And that's actually, you don't have to square that or cube it or anything, right?
Nope, nope. That's just the relationship between the diameter and radius. Yep. All right, next thing we're looking at is the circumference and the area. So the circumference is the equivalent of the perimeter for circles. You know, the perimeter, we add up all the sides, but there are no sides to a circumference. I mean, no sides to a circle. So the circumference is the outside of your circle, the line. So that's how you would calculate that. And then the area is the amount of space that the circle takes up, just like any other area shape. But the circumference is only for circles, only for circles. Then we have pi there, 3.141597, whatever, you know, this just goes on to infinity. But that's what that represents. So 2 pi r is our circle, area, pi r squared. All right, let me scroll up and do this. Pretty good. Okay. So directions: find the circumference and the area. Give the approximate. Give the exact and the approximation. So they give us this diagram. Have a line going from point to point, going through the circle, and says 20 inches. So that means that the diameter is 20 inches. You know, but we need the radius, so we would take half of that, and our radius would be 10. All right. So it doesn't matter which one you decide to find first, whether it's the circumference or the area. We can go ahead and look at the circumference first and then the area. So we know that our formula for the circumference, 2 pi r. So we're going to take that 10, which is our radius, and plug it into r. So we have 2 pi times 10. So now your exact answer is going to be your answer simplified as much as possible with pi still involved. So I take the 2 times 10, that's 20. So my exact answer is 20 pi. So don't forget to leave pi as a part of your answer for your exact. The reason why it's considered exact is because you have not used any approximation for pi. You know, approximation for pi is 3.14. It becomes an approximation once you plug that in there. But until then, it's still exact. So if you leave pi, simplify it as much as possible, multiply those numbers together, 2 times 10 is 20, and leave pi there, that is your exact answer. That gives people the option to approximate pi as much as they want. And so don't worry about this purple stuff. That was for another class. So that's not for you. But then you throw in 3.14 and you get your approximation. Once again, do not copy this purple. That's not for you guys. It's for another class. And so we get 62.8 as the approximation. Then for the area, plug in 10 for the area. We have pi r squared for that formula. That'll be pi times 10 squared. 10 squared is 100. So 100 pi is your exact answer. Then once you plug in the approximation 3.14 for pi, multiply that times 100, then that will be your approximation, which is 314. And then also make sure you hold true to whatever direction they tell you as far as round to whatever decimal value, you know, so.
Where did we get R from in this, your 10? Where'd you get that from?
Oh, right here. It's
that,
half.
that was a given?
Well, it was, they gave us 20. And because the line go end to end, that means that's our diameter. So take half of that and that'll give us R.
And what does R stand for again?
Radius.
Radius?
Uh-huh.
Radius. All right. So the radius is half of the diameter.
Mm-hmm.
All right. All right. So where it says exact to the left arrow, it says 20 pi inches.
Mm-hmm.
That's your, and you said that's your exact answer.
Yep.
20 pi inches.
Simplified as much as you can with pi still there.
Okay.
With pi still there is your exact answer. All right, are we good? Still copying? Okay. All right, let me see something. All right, so it's 12:10. Next thing is volume. So we'll pause right here. Don't let me forget to pick up at volume because that's the last part of this section. So we'll pick up with volume, knock out volume, and then go to the next section, next class. But I don't want to start volume and not be able to finish all the examples and be halfway through or something like that. So we'll knock out volume on next class and then go from there. Any questions or anything before we close out today? Everybody good? Everybody straight? See head shaking? No? All right, that's good to go. So if you guys are good, I'm good. Have a great day. Be safe, and we'll knock this out on Wednesday. Thursday. Have a good one, y'all.
You too.
Thank you.
Thank you.
Thank you. You have a good one. Yeah, sir. You all right? Take your time.
Why'd you leave it squared at the end? Why didn't you square it?
Let me sure. You're talking right.
304.
Oh,
Yeah,
hold on.
314.
I messed up my notes. Give me a second. I'm trying to get this thing back on track. What happened? Okay.
Inches squared. Square inches. All right. That just means square inches.
Yeah, let me make sure I tell you. So you talking about right here?
No, to the right.
Right here?
Yeah, why'd you leave that?
That's supposed to be there.
That's just implying the
I didn't
square
put
inches.
it here. Oh, wait, no. Hold on. Yeah, that's the
and
area.
it has to remain there. Has to remain there because it's area, and that's implied.
Uh-huh.
All right. Okay.
Mm-hmm.
All right.
Yeah.
All right. So if we didn't put that, if we didn't put that, it'd be wrong, right? It'd be interpreted as just 314 inches.
If they ask you, because I don't know for sure if they're gonna have the box and then have inches squared on the outside, you know what I mean? In which all you do.
They always try to do something.
Yeah. So
they're always trying to do something to get me.
So that's why I just give you all the information possible, and then from there, but just know that it is possible they could say what, ask you. And see, I know, because I forgot which class it was, and I need to go look. Sometimes they give you a drop-down box, and they'll give you inches squared, and inches cubed to pick from. You know what I mean? So it's just different ways they could ask you. So, yeah, so I just wanted to make sure I just tell y'all so y'all know.
But we won't have to actually do it, right?
When you say do it, are you talking about the inches squared piece?
Right. Uh-huh.
Yeah,
I mean, are they going to expect us to square 314? Which is fine, but I mean, that's the correct.
No, so the 314 is fine. That squared is just applied to the measurement. So right, you just leave the inches squared is just how you would leave it.
Oh, okay. Okay. All right. Thank you.
Not a problem.
Yeah, I do all of this stuff, man, but mine is like real simplified ways. Like I cut circles out of plywood. I put a nail in the center of my circle, and then I just use a string to go around, and you know what I mean, and do it. Like I use this, and the applied version of this is a lot easier to understand than A equals pi R squared.
Yeah. Yeah. I know. Yeah, I know what you mean.
That's why halfway through when you right after you said, oh, you just sat back, like I had to sit back up, and I was like, hold on, whoa, what is this? What is this for? Oh, I got a formula. Hold on, wait a minute.
Yeah.
But this is gonna make me better too, as as a because I know it all. Nah, let me take that back. I know how to apply this stuff in construction material.
Right.
you know, but to actually break down the math of it and whatnot, this is eye-opening for me. So
yeah,
I appreciate you.
Oh yeah, man, for sure.
Thank you.
Not a problem. You have a good one.
Thank you.
Yep, I'm gonna get out of here, man. I got an appointment.
All right.
Thanks,
Y'all
sir.
take it easy.
Enjoy your day, brother.
You do the same, man.